Today we will explain you more about Agensi Nuklear Malaysia, or we called as Malaysian Nuclear Agency. Before we go further, we must know where it's located. It's located at Bangi, Kajang Selangor, just near with our campus. How it was established, and when the first idea comes. It was established on the 19th of September 1972. ANM was then known as the Center for Application of Nuclear Malaysia, Crane. It was formally named Tun Ismail Atomic Research Center, Puspati. Then on June 1983, Puspati was placed under the patronage of the Prime Minister and was called Nuclear Energy Unit, UTN. After 11 years, in August 1994, its name was changed to Malaysian Institute for Nuclear Technology Research, MINT. On the 28th of September 2006 until now, following its restructuring, MINT was given a new identity, which is Malaysian Nuclear Agency. Mission, vision and objectives. MINT's vision is nuclear science and technology for knowledge generation, wealth creation, and societal and national well-being. And its mission is excellence in research and applications of nuclear technology for sustainable development. There are three objectives, which are to enhance organizational excellence through planning and quality management, to generate new products and technologies through research and innovation based on the National Development Agenda, and also to achieve an income, at minimum 30% of the annual operating budget, through transfer and commercialization of technology. Facilities of MINT. First, non-destructive testing services (NDT) is a method of diagnosing defect of component and system reliability without damaging the parts being tested. NDT plays a vital role in manufacturing, quality control and plant life management. It is used in a wide range of industries including manufacturing, petrochemical, power generation, transport and civil engineering. There are many advantages of NDT methods, which are tested objects or parts can be reused unless proven defective. Test can be conducted to all samples, 100% inspection, or representative samples, and many more. Next is Sanagama. The Sanagama irradiation plant uses ionizing energy in the form of gamma radiation from cobalt-60 source. Initially designed as a multipurpose pilot facility for research and development purposes, the plant activities later diversified to offer services to the public for the sterilization of medical products and packaging materials, decontamination of food, pharmaceuticals, herbs and animal feeds, and the disinfestations of insects in agricultural commodities, including for quarantine purposes. The plant also provides tissue and bone sterilization services by gamma radiation for tissue banking purposes to relevant authorities such as hospitals and National Tissue Bank. There are advantages of irradiation, which are effectively kills microorganisms throughout the product and its packaging with very little temperature effect, reduction of microbial load, and also insect disinfestation. The third is electron beam irradiation. Electron beam processing facility known as Elortron. Operated with 3 electron beam machines, EPS 3000 electron beam machine provides fast irradiation processing. ELV4 is a low-voltage electron beam machine with the energy up till 1.0 MeV, and Curetron on the other hand is specially used for R&D in surface curing and modification. It provide electron beam irradiation service to treat finished products. The facility is equipped with handling systems to treat tubal products such as tubes, wires and cables. Currently the facility is servicing commercial automotive wire and heat shrinkable tube manufacturers to crosslink their products using electron beam. Electron beam could also be used for sterilization purposes. At commercial level, Seiko hydrogel-based products such as facial mask, wound dressing and cool fever patch are irradiated for simultaneous sterilization and cross-linking. Environmental and pollution control for wastewater treatment also being included in this electron beam irradiation. Radiation vulcanization of natural rubber latex. It is a method of vulcanizing natural rubber latex by using ionizing radiation. Vulcanization refers to a process of introducing chemical bonding between rubber molecules, crosslink, within latex and forming three-dimension networks that can enhance the elasticity and overall mechanical properties of the latex. Conventionally, vulcanization is achieved by heating latex together with sulfur, whereas radiation vulcanization is a non-sulfur vulcanization method that does not require the presence of sulfur during the vulcanization process. How to vulcanize natural rubber latex by using radiation. Prior to irradiation, acrylate monomer together with stabilizer will be added to natural rubber latex. The presence of acrylate monomer will reduce the radiation dose required for achieving optimum latex mechanical properties to a reasonable amount. Radiation per vulcanized natural rubber latex is collected at the end of irradiation process. A simplified radiation vulcanization process is shown in the following animated diagram. Near assessment in industries. RF and LV/EMF measurement at production area. The main objective of the assessment in industries is to determine the presence of near radiation in accessible area of workplace. The assessment usually requested with aims to know the level of near radiation at workplace and potential near exposure received by personnel working in the vicinity area. Consultancy advice will be given on the outcomes of the assessment based on recommendations and standard guidelines issued by International Committee on Non-Ionizing Radiation Protection, ICNIRP. Next is radioisotope production, supply. The radioisotope production laboratory was established to carry out the production and distribution of radioisotopes, radiopharmaceuticals and radiopharmaceutical kits to hospitals around Malaysia and other users. The laboratory is equipped with an extensive range of facilities including clean room and freeze dryer for aseptic preparation of radiopharmaceutical kits and equipment for quality control such as multi-channel analyzer, automatic gamma counter, high-performance liquid chromatography HPLC, dose calibrator, polarography equipment, pyrogen test equipment and sterility test equipment. Next is radioactivity measurement. It provides radioanalytical services for government and commercial needs. Radiochemical analysis is performed for alpha, beta and gamma emitting radionuclides in a wide range of matrices such as soil, sediment, sludge, water, food, smear test, fauna and flora. Four main types of equipments available at Ross Laboratory for radioactivity measurement are gamma spectrometry system, low background gross alpha beta counting system, alpha spectrometry system and liquid scintillation counter. Analytical chemistry. The Analytical Chemistry Laboratory is the laboratory established under the Division of Waste and Environmental Technology. It was set up to perform important functions, namely, providing chemical analysis services to research groups within the agency, research communities in universities and other government agencies, providing commercial analytical services to private sectors, and providing training facilities and guidance to university students in handling analytical equipments. The laboratory adopts high-quality control and quality assurance practices in order to provide reliable analytical test results, which meet international standards. Currently, the laboratory is equipped with various analytical instruments, including gamma spectrometers for neutron activation analysis, (NAWC), inductively coupled plasma mass spectrometer, ICP-MS, atomic absorption spectrometer, AAS, gas chromatography mass spectrometer, GCMS, ion chromatograph and CHNS elemental analyzer. National Radioactive Waste Management. The Radioactive Waste Management Center was set up with the objective of protecting workers and the people in the surrounding areas from the health hazard due to ionizing radiation, as well as to ensure a safe environment through effective management of radioactive waste in the country. The center is equipped with facilities for handling radioactive waste generated in this country. With the availability of skilled manpower and facilities, the center is capable of providing efficient services for safe management of radioactive waste and thus protecting people and environment against radiation hazards. It is the objective of the center to ensure that the management of this waste is conformed with the laws of the country, including the Atomic Energy Licensing Act 1984. The last one is gamma cell. Gamma cell is most suitable for acute radiation on agricultural samples, seeds, cuttings, bulbs, corms, suckers and plant tissue culture samples, callus and somatic embryo to induce mutagenesis. Other applications include biological effects of gamma radiation on animal and human cells, calibration of low dosimeter and basic insect disinfestation study. Working dose rate at center reference position is determined as 7.3 gray per minute and 15.7 gray per minute when beaker BB75-4 and BB13-5 are used respectively, to contain the samples during fixed source irradiation mode. We also provide radiation service to other institutes and collaborators. Are Malaysia ready for nuclear power plant? In trademark straight-talking style, former Prime Minister Tun Dr. Mahathir Mohamad declared on September 18 that Malaysia will not use nuclear power plants to generate energy, as science has yet to find ways to manage nuclear waste and the effects of radiation. In a keynote address to the Electric Power Supply Industry Conference in Kuala Lumpur, the Prime Minister cited numerous nuclear incidents worldwide that had led to people suffering from the effects of radiation. Malaysia, he said, will continue to rely on existing fuels to generate electricity, including stable, environmentally friendly hydroelectric dams and wind power. Despite cost advantages and scientific advancements, a solution to nuclear power's drawbacks has yet to be discovered. Malaysia, he noted, had a bad experience with among, a type of irradiated ore once used to make color televisions. Its activation led to radioactive residue problems and widespread community fears. The eventual resolution was to bury the substance under thick cement in an area 1 square kilometre large. The Prime Minister said the area is still unsafe, and lost to development. The nuclear power debate has been going on for a long time. What have Malaysia done so far toward green energy from nuclear? The former Energy, Science, Technology, Environment and Climate Change Ministry has set a target of 20% of the country's electricity to be generated from renewable sources by 2030, an increase from 2% currently. Minister Yeo Bee-yin said her ministry is having a series of meetings to ensure the national grid is prepared to cater for this renewable energy generation mix, as well as to study the policies to meet its target. Yeo is confident Malaysia's electricity supply industry (ESI) transformation programs such as Future Generation for RE and Green Energy, Grid of the Future that enhance customer experience initiatives, will propel the country, going forward. Malaysia sets new goal of 20% clean energy generation by 2030. Stay tuned, with question and answer session.